In the future, those will be electric. We have arrived at the World Maker Faire in New York. The Maker Faire is an event where people can come display what they've made. It's an incredible event that combines companies selling products, startups, enterprise companies, companies that build tools that try and help people make new things. Maker Faire is an event put on by the same people that make Magazine. It's a magazine for people that enjoy DIY projects and creating things. Wandering through alleys and alleys of different companies showing off tech products. And this is a great opportunity for a lot of companies that make products that help people make other products show off what they offer. So I am here with Glowforge, and I've seen them at the Maker Faire a few times. They make some incredible products, and I think it's awesome how they combine technology and art. And there's someone here that can talk about it.
Hey! So, I'm Bailey, I'm here with Glowforge. Yeah, like he said, we actually launched at World Maker Faire New York a couple years ago in 2015. And we ended up doing a giant crowdfunding campaign for the Glowforge 3D laser printer. A 3D laser printer is a laser cutter engraver with some 3D capabilities like autofocus and material recognition. And what you can do is cut and engrave on like dozens of natural materials like hardwoods, leathers, plywoods, and the way that we really like bridge that gap between art and technology is we have this really cool feature where there's actually a camera right on the lid of your Glowforge. So if you can see behind me right now, in line people are drawing on a postcard, and then we put the postcard in the Glowforge, close the lid, and the camera is actually capturing the drawing, and then the Glowforge is going to cut and engrave directly on the drawing. So you can draw by hand, which is really for people who aren't digital artists, really amazing. And then if you are a digital artist, you can upload your own art from basically any file type. So you can use Inkscape or Illustrator or whatever your forte is. I think a big thing that makes us different is that our software is all web-based, which means that you do need Wi-Fi to operate the Glowforge, but you can do it from your phone, from your Mac, from your PC, like right. Anywhere that you can get Wi-Fi, you can run it. And you could also have friends like send a print to your Glowforge from like across the country, and you just press this glowing button right here, sure. And it'll print. So
that's fantastic.
Yeah.
It's so exciting to see these products and see products that people can use to make what they want to make something special and unique.
Absolutely.
So thanks.
Yeah,
I appreciate it.
It's nice to meet you.
Thank
Have
you.
a good Maker Faire.
love about the Maker Faire is that so many of these projects combine engineering with art. I think it's very important to be able to do that, and I'm excited to see so many projects that do that so well. Both are very important not only for product design, but to appreciate something that someone has made. It takes a lot of engineering to know how to create something, to know how to construct something that will stay together, that will do what you want it to do, but to then take that engineering design and add artistic quality to it. That's where something can really shine.
Hi, I'm Dade, and I made this stainless steel armor. I actually made it for my wedding, which was a themed costume wedding. The metal is etched with ferric chloride, which is the same chemical used to etch circuit boards. And I had to dunk this in a bath of ferric chloride and mask the edges that I didn't want it to get etched. So each of these patterns is etched separately. Well, hot, it's very hot.
We're both doctors at Beth Israel Deaconess Medical Center in Boston. He's an interventional pulmonologist, I'm a hospitalist. And we do a lot of medical simulation making, so making tools to teach doctors how to do specific procedures. So, as an example, one of the things we're making here at the show is a cardiac surgery simulator for simulating repairing the mitral valve in your heart. This is one of the key valves on the left side of your heart, and it often gets destroyed from conditions like rheumatic heart disease, which is a side effect of strep throat. So, to fix the mitral valve, we sew in this white ring called a Carpentier ring. And when you sew this in, this is actually one of the most dangerous surgeries that we ever do. And it turns out if you misplace these sutures by even a millimeter, you can actually kill the patient. And so it's so high risk that they won't let trainees, like residents, do this. So that by the time surgeons become cardiac surgeons, they haven't actually done this before. And so the question was, could we build a simulator to teach this procedure inexpensively? Because there's one on the market right now. I think it's about $1,500 and $300 every time you reload. But we have 50 surgical trainees. At $300 a reload, that's a big bill. But my chairman said, could you make that for 1%? So our goal was a $15 assembly with $3 a reload. And one of the tricks when you're making a broad-based tool like this for teaching, you have to be able to make a lot of them because they get destroyed. And so we worried a lot about how fast we can make these. So the goal is like we can make one of these in about 20 minutes. We're going to be doing this, 80, 90 times this year. One of the advantages of this specific version is that we put it on the table in the surgical library and all the residents are sitting there doing this. And in the real person, it's very hard to see down to where he's operating. And so here, the attending surgeon can look from the side, see what you're doing. And obviously the consequences aren't as bad as learning on a person. It's funny, when the surgeons asked me originally, they asked for a high quality 3D printed heart because they wanted it anatomically correct. And I was like, are you trying to teach the anatomy of the heart? Because hopefully by the time someone's operating on the heart, they know the anatomy of the heart. I mean, if not, they need to go back to medical school. We finally got down to the essence is being able to do this, like essentially operating in a hole and learning to do how to suture in this tight space. And it turns out a lot of the art is like, how do you turn your hand where you're suturing backwards and things like that. And so we got down to the only thing that really needed to be simulated was this part of the heart. When we made this, we had to invent a couple new techniques. So to make the valves, since you can't suture in silicone, the sutures tear out, we embed power mesh, which is the fabric in like women's bathing suit crotches. But as you can see, it's like completely filmy. So the air assist and the laser just blasts it out of the way. So what we do is we silicone impregnate it. But even silicone impregnated, it still blows all around. And so we had to come up with a technique where what we do is we cut out like a dotted outline, and then the laser goes back and in the direction of the wind cuts the dashes between the dots so that it doesn't blow around. And so we've been able to do precision laser cutting of fabric. And then we use 3D printed molds. And although today, I realized when I went, because we're going to be actually molding these live here, that I had forgotten one of my molds. I used the laser cutter to actually cut and stack acrylic sheets to form the mold for this part. Learning about your materials. So this is bronze filled PLA because it's radio opaque. So when you take an X-ray of this arm, the bones show up. Learning a lot of like materials, and I've been doing a lot of medical devices. So understanding what plastics are safe to put inside of people, what can be sterilized. So nylon 910 is autoclavable, so because you can't gas sterilize 3D printed plastic parts. Because ethylene oxide, if it got into the inside where the infill is, if it leaked out, it could kill the patient. It's like one of the most toxic substances. So, like understanding all the rules for being able to put medical devices into people, and learning how to embed the RFID tags that now everything that goes in the OR has to have in them inside a 3D printed part. Figuring out how to make a spinning mandrel, or as we like to call it, a colonoscopal. It's like a popsicle, but it's a colon. To be able to cast 3D colons that people can, so this was sewed up by our surgical robot to teach people how to do basic colon surgery. Learning how to do like a spinning mandrel, which is how you make hose, like garden hose, but it's obviously not regularly shaped, so it was quite a challenge. And we embed the fabric inside that. And so we had the challenge that since it's not round, figuring out the distance, it's not even cylindrical, right? It's wider here at the base of your colon where your cecum is. So we had to figure out what to do with the extra fabric as you wrap it around. And the nice thing is you see these stripes on the side, which are your tinea coli, and in real life, that has a thicker fibrous band in your real colon. So we're like, oh perfect, we'll fold the extra cloth there. That's just like in real life. That part of your colon doesn't stretch well.
This is Plus Farm. It's our DIY hydroponic farm. You can find all the instructions for how to build it and grow with it online on its website. So this is no soil, artificially lit. We don't sell the product directly, but it's completely open source and DIY. So we created this website where you can learn about hydroponics and vertical farming. And then you can see where to buy all these materials online. Most of them come from Amazon and Home Depot. We're actually releasing it as a kit later this week where you can go on, we partnered with a hydroponics store online, and then you can go on and just buy the entire kit in one click. We're really just providing the educational resources that go with it. So we provide all the instructions for how to build it. We have a really detailed grow guide on like how you actually manage your plants once they're in the system. It's hard to get all of the info you need to get started when you're someone that doesn't know about hydroponics, so we really geared this towards those people who want that first step. With our guide, we really went like step by step, like this is how you put your rack together. You know, this is how you cut your pipes to build the PVC plumbing. This is how you assemble it, etc. So we tried to make it as easy to build as possible, even for someone who doesn't have experience building.
So this is meant for more urban environments?
Exactly, yeah. So it's mainly meant for, I mean, you could do it in a non-urban environment too. It's ideal for urban environments because, you know, often in urban environments you're very limited on space, and this is very space.
Especially with the ability to go vertically. That can be important for those areas.
Exactly. Yeah.
Is this somehow computer controlled?
It is not currently with the system. Normally we have timers for the lights and the pumps.
Okay.
We also have, normally we have sensors for both the nutrients and the pH of the water. We didn't bring those here today, but we're actually planning on creating a DIY controller kit for the Plus Farm.
Good product integration.
Yeah.
Thanks,
great.
I appreciate
Thank
it.
you so much.
Chris, what is the coolest thing that you've seen so far today?
I think the coolest thing I saw so far was actually the Power Racing series. Just a lot of people having a lot of fun making ridiculous go-karts and absolutely hilarious presentations. My understanding, it's a $500 or less go-kart, and then you compete in a team, and that's like there's some safety requirements, but I think that's kind of it. There might be a size limit. They're very open-ended.
Teams theme themselves and teams theme their vehicles, and they make it exactly what they want, so they can race and have fun in a competitive atmosphere, but one that is honestly more focused on fun than winning.
Which is what I really like. You know,
Yeah.
if you can be fun and introduce people to building stuff as well, that's how you should do it.
I met up with Hogan Eng. Hogan and I met 9 or 10 years ago on a FIRST Robotics team, and so it's so great to see you here.
Great to see you guys too.
And if you could, tell us a little bit about what you do in your work.
Okay, sure. I'm an electrical engineering manager at ebm-papst, and what we do is we make value-added electronics and assemblies around fans that are built in Germany. But just in the next year, we're going to be starting a new department called the Research and Development Department, and where we will now start to develop fans in the United States as opposed to just in Germany. So Germany has this global plan of having all the manufacturing sites around the world. So in the next year, we'll be learning to do our own motor drive electronics, our own castings for housings, and blade design. So it's kind of a very interesting new venture for us. We're kind of moving into the bigger research for product development as opposed to a custom product design that a specific customer wants.
Right. FIRST Robotics is also a very big part of your life, and we were on the same FIRST Robotics team. So why should a working professional also be a part of a FIRST team?
Well, you know, when I've been lucky enough to have a pretty successful career in engineering, I've learned a lot. And sometimes when you see some students in high school that aren't sure where they want to go, you kind of want to show them a direction of engineering. Maybe you can do this. And when you show them that they can do it, it kind of develops an interest, and then you kind of say, hey, I may have affected the future career of the student that now wants to go into engineering. Plus also on the corporate side, we maybe want to look for future engineers that have a head start, have the mentality of how to enter the workforce a lot faster than maybe students that didn't have experience at first. So they have now come back to the company as a planted seed now comes back to help the company in the future. So this is where our future prospects come from for engineering.
Having worked with a lot of high school students and then hiring students out of college, what are the qualities that you most look for in a job candidate?
Yeah, a lot of people think that maybe you look for the best grade point average, and it's not necessarily that. When you work in a collaborative environment, you want to make sure that people get along and work together well. Because you can have one person that doesn't get together well, it can bring down the ability of others to work well. So by having someone who works well with a group, you can bring up the productivity of the whole group, and it's more than the sum of the parts. It's really kind of like a product of the parts. So I really look for someone who can work with others well.
That's very important.
It's very important.
I appreciate it.
Right.
I appreciate you being on the blog today. Thank you.
No problem. Thank you. Nice talking to you again.
Right now I'm wandering through the 3D printing village. This is a section of the fair where they have companies, usually startups, that are making 3D printers. And I think it's fascinating because these companies are trying to one-up each other, trying to make sure that they can make a better product than all of their competitors. It's amazing to see this new technology that is really starting to hit its stride right now as all new industries spring up. It's going to be interesting to see how these companies compete with each other and then which ones survive. It's an interesting test of product usability, product reliability, and ultimately what a creative person can do with a tool. Thank you for the shade.
You're welcome.
I'm Daniel. We're here in the Dremel booth at the New York Maker Faire, and Dremel announced today that they will start selling a laser cutter next year in summer, so summer 18. We have some lasers running here at the booth. This is a 40-watt laser, CO2 laser, water cooled with a bed size of 12 by 20 inches. Yeah, as I said, we'll be launching it next year in summer, so we're excited about it. These are pre-built units, so these are not just prototypes, but we're further along. These are pre-built units. We're well known for our rotary tools.
Right.
That's where our heritage is. We have 85 years of Dremel this year. And we're venturing it out. So out to a new world. We started with the 3D
That's right.
3D printer.
Yep.
I think it's 3 years or 4 years now. And so this is our latest digital product.
And I think I remember the first time I saw your 3D printer, it was at a Maker Faire.
That's true. I think it was announced at this Maker Faire, actually.
Okay.
Yep.
Well, thank you very much. I appreciate it.
Thank you very much.
I found Rachel, who you might remember from episode 2. And Rachel is here representing SDC, the Satellite Development Club again. Why did you bring SDC to the Maker Faire today?
Well, it's a great opportunity for the Satellite Development Club to teach the public about CubeSats and about what we do. We meet some interesting people while we're here. We always do. We meet, old professors from WPI. We meet people who work for NASA.
True.
We've made some good connections that way with other schools as well. And so it's always an interesting experience getting to practice public speaking, getting to talk about what we do, and we've really enjoyed it.
In addition to being such a fun event, it's an incredible networking event.
It is.
I mean, there's so many people here from different walks of life in different industries.
We get the whole spectrum of kids who have never seen, a satellite before, to people who have worked on these things, people who just read science fiction.
Events like this one show the importance of explaining why you're doing what you're doing.
Yes.
Making sure that what you're doing has relevance and that you're finding a way to help other people appreciate what you do. Great to see you at Maker Faire today.
You as well.
What I appreciate the most about the Maker Faire is the variety of exhibitors. There are people here from the largest tech companies, and there are children here displaying projects that they've made. Whether it's an enterprise project that will make a company millions of dollars, or a project by a child that will set them up for a lifetime of curiosity, it all matters. So if somebody creates a piece of art, or an engineered system, a drawing, a play, a piece of music, whatever it happens to be, it all matters. Because the coolest people are the people that make things. Chris, how was your day?
Awesome.